Welcome back, College Algebra. In today's video, we're going to be talking about polynomial and rational inequalities. So, what we're going to be working with is inequalities just like this one, and we're going to find out where one function is less than another. So here, on this graph, the red one representing the rational, we want to find out where it's less than 4x. And so here, this blue line represents where it is less than that line. And so we're going to come up with inequalities that describe where the function is less than the other. Okay, so let's go ahead and get started. Before we move on to determining when a function is less than another one, I want to discuss interval notations. And just to remember, when you include a number, so when you're including -2, you have a closed bracket. And when you don't include a number like 6, so we're going from -2 to 6, and we don't include 6, we have the parentheses. And so, or all numbers from 10, so we didn't include 10 there, to infinity, parentheses around infinity. And same goes down to here, numbers from -infinity to 5 and including -5, and 5, not including 5, all the way up to 12, including 12. Now, this little u thing here, all that represents is the word or. So you can either have your numbers in the interval, -2 to 6, or the interval 10 to infinity. That's all that little u stands for. You guys will be working with that here in a little bit. Okay, so I would take notes on these steps. What you wanted to do here was with these inequalities, you're going to want to set everything to 0. And then for number 2, you want to find your zeros and vertical asymptotes. When dealing with rational functions. And then we're going to split it up into ranges or intervals. And then we're going to pick points to determine whether or not our function is positive or negative in that range, which will help us determine where it's greater than or less than our other value or other function. And we look at what you wanted to originally, and so that's where we'll decide here with this positive and negative stuff. Anyways, these last couple of steps might be a little confusing, but they'll make sense in a second once we go through an example. Okay, so when we want to solve this inequality, the first step said for us to set everything equal to 0. And so we move everything onto one side. I'm moving everything onto the left side. So this is greater than or equal to 0. Okay, now, this function right here we can actually factor down. And it'll factor down to 2x minus 3 and 3x plus 2. And this is still greater than or equal to 0. Okay, now, our second step asks us to find our zeros. So here, one of our zeros are going to be 3 over 2, because we plug 3 into 2 into this x, we'll get a 0. And it's also equal to -2 over 3. Okay, now what we want to do is create a number line from -infinity to infinity. And this is part of step 3. And we want to plot our zeros under here. It says a number line. Get 3/2. Oops, other way around. -2/3 and 3/2. Okay, now that we have our zeros, we need to figure out when we are greater than 0. So what we do is we pick values to the left and to the right of each of our zeros. So we could pick -2 as one of our values, 0 as a value because 0 is between -2 over thirds and 3/2. And let's just pick 2. Okay. Now, when we plug all these values in, we're going to get a negative value here. When we plug 0 in, oops, I'm sorry, this should actually be a positive number. When you plug -2 back into all your x's here, you'll get a positive number. Here when you plug 0 in, you'll get a negative. And then when you plug 2 back into your function, you'll get a positive. Okay, so what we're trying to figure out here is when our function is greater than 0. And so that means it has to be all positive numbers. So right here from this range, from here to -2/3 into 3/2 all the way out to positive infinity. And now we can write that in interval notation as -infinity to -2 or 3/2 to infinity. Okay, let's look at another example. Okay, here, first thing we do, get everything onto one side. All right, now let's factor. We'll get x squared times x minus 3 is less than 0. And now our zeros here are 0 and positive 3. Okay, now we create this number line with all the zeros on it. So we have a 0 here, and we have 3. Now what I want you guys to do is pause the video and go ahead and tell me where our interval, or what intervals of this function here are less than 0. So go ahead and pause the video and figure that out. Okay, so I chose the values -1, 1, and 4 to plug back into our function, determine or not whether if they're negative or positive. And so since we're trying to be less than 0, we're trying to find negative numbers. Okay, and so we can set up this interval as -infinity to 0. But doesn't it include 0? Well, why doesn't it include 0? Notice in the last example, we set it equal to 0, greater than or equal to 0. And so that can include any of our zeros. But here, since we did not include our 0, since it's just less than, we have to make it a parentheses. And now it's also negative from 0 to 3. And those are both of our intervals. Okay, now what do we do about this type of inequality? Well, it's just the same thing. Set it equal to 0. So you have x plus 4 is less than or equal to 0. Now, we really don't know where zeros of this function are or what our asymptotes are. So what we need to do is come up with a common denominator. We'll multiply that 1 by x minus 2 divided by x minus 2. Notice how they have a common denominator, and this is still less than or equal to 0. Now we can set this up as x plus 4 minus x plus 2. You get that minus x because this subtraction sign is going to carry on to both sides. You can divide this all by x minus 2. Okay. Now if we were to simplify this, we cancel out our x's because x minus x is 0. And we'll get 6 divided by x minus 2 is less than or equal to 0. Okay, now, in these steps from before, I mentioned that we would also need to find our vertical asymptotes. Okay, if we go back to our example, here we do not have any zeros, but we do have a vertical asymptote. So our vertical asymptote is x is equal to 2. Now we can graph that on our number line. So here would be our 2. Now let's go ahead and find values to the left of 2 and to the right of 2, see whether or not they're positive or negative. Okay, so when we plug in 1 into our function down here, we'll get a negative number. And when we plug 3 into our function for x, we'll get some positive number. Now, we wanted a value less than or equal to 0, so we'll have some function from negative infinity to 2. But here's the tricky part. We said it's less than or equal to, so shouldn't we just have a bracket like this? Well, the answer is actually no. We cannot include that because it's a vertical asymptote. And what that means is that when we plug 2 into our x here, we're going to get a 0 in our denominator and get something that's undefined. Remember, we can't divide by 0, and so therefore we have to have a parentheses instead of a bracket. So that's the big difference between vertical asymptotes and zeros in this case. Okay, so let's look at one more example. First thing we do, set it equal to 0. Get everything onto one side. Okay, now this hopefully looks familiar from way back dealing with rational expressions. But what we want to do here is come up with a common denominator. And so to do that, we'll multiply this side by x plus 1 over x plus 1. And then we'll multiply this left side by x minus 3 divided by x minus 3. Okay, and when we do that, we will get 5x plus 1 minus 3x plus 9. Remember, this negative gets distributed. All divided by x plus 1 times x minus 3. And this is still greater than 0. Okay, let's go ahead and simplify the top. We'll have 2x plus 10 is less than x plus 1, x minus 3. And I'm going to leave it in this form and not multiply everything through because it's very easy to see what your zeros are and what your vertical asymptotes are in the denominator. Before I move any further though, I actually made a mistake. There should be a plus 5 because you're multiplying this 5 by the 1. And so this will actually be 14. That's all. All right. Zeros of this function are, so when we're trying to find our zeros, we look at our numerator, and it's going to be negative 7. Because when we plug negative 7 here for x, we'll end up getting our numerator as being 0. Now, what are our vertical asymptotes? Okay, that's where we look at our denominator, when those will equal 0. And so vertical asymptotes is x is equal to negative 1, and x is equal to 3. Okay. Now let's go ahead and draw a number line. And put on a number line our zeros, negative 7, and our vertical asymptotes. All right. Now we're going to have to pick 4 values to determine where it is greater than 0 or determine where they're positive. So I'm going to pause the video and figure that out. Okay, so when we plug in our values, negative 8, we end up getting a positive. So we get some interval from negative infinity to negative 8. And it's a closed bracket because negative 7 is a 0. Oh, this should be negative 7. Negative 8 is not the 0. Or we have the interval from negative 7 to negative 1. But now that was a vertical asymptote, so we have to have a parentheses there. Or 3 to infinity. We skip the interval negative 1 to 3 because those are negative values. Now, some of you guys might be thinking here, couldn't these two be combined in the same interval? Because this includes negative 7 and this includes negative 7. And the answer is yeah, we can actually write that as one interval. We can write it from negative infinity to negative 1. Finish it up like this. Okay. So in today's video, I'm just going to recap from the beginning. You guys are able to find where polynomials are greater than each other. And so here what we do is subtract this 4x, say that this is greater than 0, find the common denominator, and find inequalities to describe where this rational function here is less than 4x. Okay. There'll be some nightly questions posted for you guys. Other than that, I'll see you next class.